Hello everyone, in this video I'm teaching you how to solve a simple problem in Gusek. We want to solve the TCP problem. We already had it in lecture 2. We solved it through graphical method. Now we want to build a model in Gusek and find the optimal solution. You need to download Gusek software from the link that I already provided you in the lecture note. After downloading, please unzip it, then just open the file, open gusek.exe. You don't need to install it, you just need to open that file. Unzipping is very important. It doesn't work without unzipping the folder. Then open a new file and save it. So I'm gonna save it as TCP as a name, then .mod. It's very important to write down the .mod. MOD stands for model. So you need to write down the extension as well besides the name. This model has two variables, x1 and x2. So first, before writing any equations, any constraints or objective function, we need to define these two variables. The command that you can use to define variables is var, stands for variable, var space, then x1. Similarly, var x2. At the end of each line you need a semicolon. Here in this model we have upper bound and lower bound for each variable. For example, x1 is greater than or equal to 0. So after defining your variable, before the semicolon you can write x1 greater than or equal to 0. Also x2 is greater than or equal to 0. You also have x1 less than or equal to 9. 9 is the upper bound of this variable. So I'm gonna put enter comma here, then less than or equal to 9. So 0 is the lower bound and 9 is the upper bound for variable x1. Pay attention that you don't need to write x1 less than or equal to 9. Not just need, you shouldn't do that because it's gonna give you an error. Comma less than or equal to 6 for variable x2. After defining your variable, it's time to write the objective function, its minimization. So you want to minimize a function. Each function or constraints in Gusek needs to have a name. For example, it's zeta here. It can be cost, profit, yield, whatever it is, a meaningful name. The objective function is 20 multiplied by x1. Just write down whatever you see on your paper. Plus 15 multiplied by x2, semicolon. Then subject to a series of constraints. Again, each constraint has a name. For example, C1. Then a column. What is this? What is the constraint C1? Is 0.3 multiplied by x1 plus 0.4 multiplied by x2 greater than or equal to 2, semicolon at the end. Constraint C2, 0.4 multiplied by x1 plus 0.2 multiplied by x2 greater than or equal to 1.5, semicolon. C3, 0.2 multiplied by x1 plus 0.3 multiplied by x2 greater than or equal to 0.5, semicolon. If you don't have less than or equal to 9 for variable x1 here as an upper bound, you can add it as a fourth constraint in the subject to section. So I'm gonna delete that one and add it here to see how you can have similar results by having different definitions, different codes. x1 is less than or equal to 9. So if you have a fourth constraint like this, x1 is less than or equal to 9, it's gonna be the same as having x1 less than or equal to 9 when you define the variable x1. So I'm going to keep it back that way. Greater than or equal to 0, less than or equal to 9. Same thing. You already have the objective function and constraints. It's time to solve the model. So write down solve and then end. Before hitting this button go to solve the problem, you need to go to Tools menu and check this option, Generate Output File on Go, because we want to see the output file. So uncheck that option. As you see, it has a check mark. Then run the model. It says that optimal LP solution found. So we have the optimal solution. Status is optimal. The objective value at optimal point is 92.5, as you see it here as well. The values of variable x1 and x2 are 2 and 3.5 respectively. Lower bound and upper bound of these variables are 0, 9, 0, 6. The current value is 2 and 3.5. This is the optimal solution with this optimal objective value 92.5. As you see, we have two tabs here, tcp.mod for the model, tcp.out out for the output or result. Let's solve the other example, the modified TCP. Since they are very similar, we just have 3 more variables. I would like to copy all of these commands in the model. So copy them, open a new file, paste them here. Let's save this file too. I'm gonna save it as tcp1.mod, the modified version. Besides variables x1 and x2, we have variable y1, variable y2, and also variable y3. Also, all of these variables have a lower bound of 0. If you don't have greater than or equal to 0, they will be free variable. They can get 0 values as well, negative values as well. It's minimization of 20x1 plus 15x2 minus 10y1 minus 14y2 minus 8y3. Subject to the left hand side of the constraints equal to 2 plus y1. Just copy whatever you have on paper in your Gusek software, plus y2 plus y3, and that's it. Let's run the model. Again, optimal solution found. Optimal linear programming. LP stands for linear programming. It's optimal. The solution, the objective function at optimal point is 84.9. The values of x1, x2 are 2, 3.5. The only value, the only positive y is 0.95. y1 and y2 are 0.